Welcome, an initiative by Kikewa College of Horticulture, Nasik, from Department of Soil Science. I, the Professor Ines Gogre, will going to deliver an audio-visual learning for students on topic Krebs cycle or TCA cycle, or it is also called as citric acid cycle or aerobic oxidation of pyruvic acid. So, what do you mean by Krebs cycle? The most nearly universal pathway for aerobic metabolism is cyclic series of reactions termed citric acid cycle or Krebs cycle. It takes place in mitochondria. It brings about compound condensed oxidation of acetyl coenzyme A to CO2 and water. It is a cyclic sequence of reactions which is the electron transport system, which reduces oxygen while generating ATP. The final common path for oxidation of fuel molecules is amino acid, fatty acid, and carbohydrate. This proceeds in a cyclic way by 8 enzymes catalyze the reaction. The total energy output for glucose, 1 mole of glucose gives 38 moles of ATP, that is 8 ATP from anaerobic glycolysis plus 3 moles of TCA cycle. In this cycle, which is termed as a tricarboxylic acid cycle, because it was then not certain whether it's a citric acid or some other tricarboxylic acid. Example, isocitric acid was the first product of the cycle. However, now it has been known that the first product is indeed citric acid, and thus the use of this name is since been discouraged. Then reaction or steps of the citric acid cycle or TCA cycle. The step number 1, condensation. Step 1, condensation of acetyl coenzyme with oxaloacetic acetate. The cycle starts with condensation of a molecule of acetyl coenzyme with oxaloacetate to form citric acid as shown in the figure. The condensation is brought about by citrate synthetase. The reaction includes acetyl coenzyme A plus oxaloacetate in presence of enzyme citrate synthetase. Upon condensation, produce citric acid plus coenzyme A plus H2O, H plus. Then step 2, isomerization of citric acid into isocitric acid. This isomerization takes place in 2 stages. First stage involves a molecule of water is removed from citric acid to form cis-aconic nitric acid. Then second, the molecule of water is added again, but H plus and OH minus ions are added at different sites to form a molecule of citric acid. These two reactions are brought about by same enzyme known as acutinase, which requires ions as activator. The reaction citric acid in presence of acutinase minus H2O gives cis-acetonic acid, which in presence of acutinase minus H2O produces isocitric acid. Then step number 3, that is oxidative decarboxylation of citric acid, isocitric acid. The isocitric acid produced in step number 2 now undergoes dehydrogenation brought about by isocitrate dehydrogenase to form oxalosuccinic acid. But this is never released from the enzyme. It is further decarboxylated and alpha ketoglutarate acid is released by enzyme isocitrate dehydrogenase. The NAD dependent enzyme is located in mitochondria and concerned in citric acid cycle. The reaction in total isocitric acid in presence of isocitrate dehydrogenase produce oxalosuccinic acid which again undergoes by enzyme isocitrate dehydrogenase which produces ketoglutaric acid or alpha ketoglutarate. Then step number 4, oxidative decarboxylation of ketoglutaric acid. In this step, ketoglutaric acid, which is produced in step number 3, is oxidatively decarboxylated to form succinyl coenzyme A and CO2 by the enzyme alpha ketoglutarase dehydrogenase with magnesium ions. The reaction in total ketoglutaric acid plus coenzyme A plus NAD plus undergoes by enzyme ketoglutarase dehydrogenase, magnesium as a catalyst produces succinyl coenzyme A plus CO2 plus NADH. Then conversion of succinyl coenzyme A into succinic acid. In this particular step, succinate thiokinase converts succinyl coenzyme A to succinic acid. Then the energy released by hydrolysis of coenzyme A bond is utilized for conversion of molecule of GDP to GTP. This can later interact with EDP to form ATP. The reaction in total, that is succinyl coenzyme A plus GDP in presence of enzyme succinate thiokinase under magnesium as activist or activator produces succinic acid plus GTP. Then step number 6, that is dehydrogenation of succinic acid to fumaric acid. The succinic acid loses 2 atoms of hydrogen to form fumaric acid by enzyme succinic acid dehydrogenase. The hydrogen is transferred to FAD to form FADH2. Succinic acid reaction in total. Succinic acid plus FAD, which undergoes enzyme succinic acid dehydrogenase, produces fumaric acid plus FADH2. Then step number 7 involved in reaction, that is hydration of fumaric acid to malic acid. Fumaric acid takes up a water molecule by the action of fumarase to form malic acid. The reaction in total is fumaric acid or fumarate, which undergoes enzyme fumarase plus H2O, produces malic acid. Then step number 8, that is dehydrogenation of malic acid to oxaloacetic acid. The malic acid now undergoes dehydrogenation to form finally oxaloacetic acid, which is one of the 2 components that form citric acid to start the cycle. Malic dehydrogenase is the enzyme required for this reaction, and NAD plus acts as a coenzyme. The reaction in total Malic acid plus NAD plus under enzyme malic dehydrogenase gives oxaloacetic acid plus NADH plus H plus. This is steps or reactions involved in TCA cycle, Krebs cycle or citric acid cycle. This is all about Krebs cycle, citric acid cycle or TCA cycle. Thank you.